To validate autonomous driving functions, conventional VNV methods seemed not sufficient. So how to make sure that the system is safe enough? Hi, I'm Nabile, and I'm happy to ask this question to Matthias Büker, head of our Process and Standards Department at our headquarters in Oldenburg. Hi, Matthias.
Hi, Nabile. Indeed, this is a complex topic, and an autonomous vehicle has to act in an environment which is almost infinite, and it must be able to handle every driving situation while still ensuring safety regarding all traffic participants. And in the verification and validation process, we need to show that the system is safe in all these driving situations that may occur in the ODD.
Okay, so how to proceed? Is there a standard providing a systematic approach for that?
Well, not only one, but the key standard for this aspect is the ISO 21448, which is known as Safety of the Intended Functionality, also SOTIF. And you can see it as a complement to the ISO 26262. So while the ISO 26262 will ensure that EE components are free from hardware and software faults, SOTIF will help making sure that the autonomous function behaves as expected and safe in all foreseeable and unforeseeable situations.
Okay, and can you describe maybe some key aspect of the SOTIF VNV process?
Yes, I believe there are three main challenges for SOTIF VNV. So first, we know that test and simulation will produce a high number of results, and you can just not evaluate them manually. And therefore, the pass-fail criteria need to be formalized to enable an automated judgment whether the system behaves safe and as intended. Second, there will always be a residual risk. So we need to answer the question, how safe is safe enough? And in order to do this, acceptance criteria need to be specified, which define under which conditions an unsafe behavior is acceptable. And the most prominent and accepted example for this is to compare the system with a skilled human driver using static or behavioral models in relevant scenarios.
Okay, I see. So this sounds related to the known scenario, but as you said, we may not know all scenarios upfront, right?
Yeah, right. And that's actually the third aspect. We must also develop arguments that the system will not induce unreasonable risk in unknown scenarios. And for this, we need to do make the set of unknown scenarios as small as possible, using extended and automated exploration of known scenarios. And B, generate evidence, usually in probabilistic terms, that the residual risk is still acceptable in unexpected situations.
I see. So sounds good. So in summary, in our VNV process, we must first be able to measure the safety goals and the intended behavior formally, right? Secondly, we must describe and assess the acceptance criteria also formally. And last but not least, we must reduce the space of unknown scenarios and make sure that the acceptance criteria apply also in this area. Thank you for watching. If you enjoyed this video, please give it a like, and if you're interested to learn what BTC is doing in the area of autonomous driving, please reach out to us.